In this video, we will tackle a classic fluid properties problem involving calculating the mass and weight of kerosene in a tank. This is a fundamental concept in fluid mechanics. Let's break it down step by step. From the question, we're given the density of kerosene as 800 kilograms per cubic meter, the height of the kerosene in the tank as 5 meters, and the dimensions of the tank as 2 meters wide and 3 meters long. Our goal is to find the mass and weight of the kerosene. The first thing we need to do is understand the problem. The question gives us information about density, which relates mass to volume, and the dimensions of the tank that we can use to calculate volume. Let's start by visualizing the problem. Imagine the tank, filled with kerosene up to a certain level. We know the dimensions, so we can calculate the volume of kerosene. The volume of kerosene in the rectangular tank is calculated by multiplying the length, width, and height. In our case, that's 3 meters long, 2 meters wide, and 5 meters high. That gives us the volume of the kerosene equals 30 cubic meters. Now that we have the volume and we already know the density, we can calculate the mass. Next, we use the density equation where density is equal to mass divided by volume. We can rearrange this to solve for mass. Mass equals density multiplied by volume. We have the density as 800 kilograms per cubic meter and the volume as 30 cubic meters. Let's plug those values in. Notice how the cubic meters cancel out, leaving us with kilograms, which is the correct unit for mass. So, the mass of kerosene is 24,000 kilograms. Now, let's calculate the weight. Weight is the force of gravity acting on an object. It's calculated by multiplying the mass by the acceleration due to gravity, which we'll approximate as 9.8 meters per square second. We have the mass as 24,000 kilograms and gravity as 9.8 meters per square second. Let's plug those values in. The unit for weight is Newton N. So, the weight of the kerosene is 235,200 newtons or 235.20 kilonewtons. There you have it. We've calculated both the mass and the weight of the kerosene in the tank. Remember, understanding the relationships between density, volume, mass, and weight is crucial in fluid mechanics.